All right, so there are a few pending topics. Am I audible?
Yes, sir.
Yeah.
A few pending topics in machine learning industry. We need to conclude that. So we complete feature selection, metrics, scaling, resampling, imbalance data set, right? Oversampling, undersampling. We have not completed this. We have I will discuss it as part of generative AI, this one, because there are few things that are more need to be added for clustering. So there are latent distillate, and this is better to discuss in generative AI, not now. Hyperparameters we haven't completed on ensemble, and hyperparameters and ensemble. Okay, let's start with decision tree. So decision tree, we are going to understand how this is going to work internally. So decision trees are going to be like inverted, right? Inverted trees. It's going to be like this. Hierarchical data structures, right? Question is, let's take that we have input columns, feature X, feature Y, feature Z, and target column is class. It's going to be like this, hierarchical structure. Okay. So the question is, which input column should come as the parent node? So that it is going to, most efficient need to be picked so that the whole tree is going to be much less. So that we can fastly, we can speed up the navigation and get the output. That's the whole idea. Now the question is, I have taken an example here. Feature X, feature Y, and feature Z. Which out of these three input columns, which one need to be taken as the best one? So basically, it's going to be judged based on purity, and purity has two formulas: information gain, otherwise called as cross entropy, or simply entropy, and the other one is Gini. Gini is the old one. We mostly rely on this cross entropy or information gain. The formula, even though it appears to be very complex, when it comes to, if you learn it by example, it's not going to be difficult to understand. Okay. Let me start with this. So we need to judge which one is best, right? So we're going to go with each column basis. Feature Y, I have given the complete explanation for feature X. But feature Y, I have not given any explanation. The reason for that is, if you look at this one, feature Y has three set of values, right? Three unique values: ugly, good, and bad. When it comes to this one, it is only smart and dumb. So I thought that it is going to be quite easy to classify it this way, rather than having this one and making it more complex and making it more complex to navigate. So we can even calculate for this one, but I have skipped it for Y. I thought that the purity is going to be much bigger than X. So I have calculated only for feature X and feature Z. So let's get into feature X for now. So we have how many values we have here? Unique values in feature X. It is smart and dumb. There are only two, smart and dumb. And class, a target variable, we have how many classes again? A and B, right? Under smart, how many A's and how many B's we have? 1, 2, 3. I think it's already been sorted. Smart, we have 5 smarts. Out of 5 smart, we have 4 A's and 1 B, right? That is what this A4 and B1 means. Under dumb, we have 2 B's, no A's. So A is 0 and B is 2. Any questions up to here?
No, no, sir. So, but why was that smart was given as false in one of the values?
Which one is false?
False means the smart was given class A, right? Okay, sorry.
You didn't even ask the question. Okay.
I just thought it is like true or false, something like.
Okay. So the next one is when we want to calculate entropy for the whole tree, we need to calculate first of all, we need to calculate left node entropy, and then we need to calculate right node entropy, and we need to calculate combined entropy. So we can't directly jump and find out the overall entropy. First, we need to focus on left, and then right, and then combined. Left node entropy, the way we need to calculate is, it's overall here is 5. The overall here is 2. And total it is 5 plus 2, 7, right? 4 plus 1 and 2. Total is 7. Okay, let's focus on left node first. So 4 by 5, we got 4 by 5 from this one. 4 total is 5, right? 4 plus 1, 5. Multiplied by log of base 2, 4 by 5. Plus, of course, it's minus of everything, right? So 1 by 5. 1 by 5 means 1 total 5. So into NP log of 1 by 5. This is for the left node. After calculating this, we got the summation as negative. There is some negative value for minus 0.72. A minus of minus is plus, right? That's the reason we got 0.72. Any questions on left node entropy? If you understand this, the remaining concept going to be quite simple.
Sir, are those values, I mean, how we arrived 4, 5, like, are
Okay,
these?
very good question. So I haven't listened to the previous explanation, right?
Okay, these are all numbers, 4, 1.
I think you haven't listened to the explanations. We started with this one, right?
Yeah,
Smart. How many smarts we have? Out of this under smart, how many A's and B's we have?
yes. Yeah.
What do you mean by yeah?
Okay, just can you little bit scroll down? Okay, 4 plus 1, we have arrived based on that one. Okay.
Okay, I request you to watch the recording again because
Yeah, I got it. Yeah, I missed that
in
one.
fact, I clearly gave an example how we got this 4, 1, and 2. All right, so any other questions? Next one is
No.
we calculate left node. Yeah, go ahead.
No questions.
All right. The next one is right node. We calculate left node and we need to calculate right node. Right node is much simple, right? Because A is 0, the same formula. 0 by 2, isn't it? 0 but I have not given 0 by 2. Straight away gone to this one. So anyway, it's actually minus of something, but it's 0, right? That's the reason I have not given that minus. So it's actually 2. The remaining part is 2. So 2 by 2. 2 by 2 into log of 2 by 2. Log 1 is basically 0. Anything multiplied by 0 is anyway 0. So its total right node is 0. So the only thing that we have value is for the left node. All right, now we need to calculate combined entropy. We got
Sure.
left. Go ahead.
So is the minus value, I mean, outside of the bracket, there is one minus, right? To make the
Right.
values as positive, you are putting that one, or like, is it in the formula?
The formula itself like that.
Okay.
The combined the combined entropy is, now we need to calculate for overall. If you look at this 0.72 here, you can see that, right? And of course, 0 is here. This is 4 plus 1, that is 4 plus 1, 5 by overall 7. This 5 by 7 multiplied by 0.72. This is 2 by 7. 2 by 7 multiplied by, what is right node entropy? This is 0. Okay, any questions on this part?
No.
Second. All right, so what we got here is 0.51. So we need to subtract 1. Actually, the formula is 1 minus. So what we got here is 1 minus 0.51, which is 0.48. Okay. Same way, we need to calculate for Z also. Z, we got this one. So A3, In under hot, A are 3 and B are 2. Under cold, A is 1 and B is 1. So we got this map, right? So the same way, we need to calculate left node entropy and right node entropy. So how do we do this? Minus 3 by 5, log of 3 by 5, and 2 by 5. Okay, sorry, this is 2 by 5. Left node we are calculating. 3 by 5, log of 3 by 5, plus 2 by 5, log of 2 by 5. This is left node. Same way, right node, this is basically should come down. I think I messed up this one. So 1 second, let me sort this out.
At the last, there was 1 by 2 something.
No. So the way I ordered it, so it got messed up.
Yeah,
So,
yeah.
This one, okay. So this is information in for X, and it should Y. Okay. Left and right nodes. Okay. Info feature Z. Okay. So this one I need to move it up, up. Okay. Now this is much better. The same way, 3 by 5, log of 3 by 5, 2 by 5, log of 2 by 5. That is for left node. Right node, this is
1 by
yeah,
2 or
1 by
something.
1 by 2, 1 by 2 log of 1 by 2, 1 by 2 again, log of 1 by 2. Let me do that. Yeah, so I think this is Guinea actually. I don't know how it got there. Okay. Again, it's not even 5, it's actually 2. Okay. Okay, this is not related to this one. This is basically, I need to make it down. This was much better. Now they messed up with the latest version. We used to have this here. All right node entropy. We got right node entropy, and the combined is this is 5 by overall. It is 5 plus 2, right? 7. 5 by 7 and 2 by 7. 2 by 7 and 5 by 7. 0.97 and 1, right? So right node entropy is 1 and it is 0.97. So 0.97. But this is 1 minus 0.97. Actually, 1 minus I would have written right here itself. Is this right?
Don't we have to divide it only multiplication?
Yeah, only multiplication. But of course, this part is anyway, there will be some division. 3 by 2, that is 5 by 7.
Yeah, total number.
2 by 7, yeah, that will be there. 0.59. 0.48. So actually, whichever has a low, I mean, higher of, actually this, I don't know why got this 0.97. Let me calculate
Left
this
node.
one.
Yeah, left node entropy. That
This
is
is for the, this is
0.97.
for the combined, this one combined. 1 minus is basically, okay, I would have, okay, so the reason would have been, I know, the overall, I should have wrapped it in round brackets. Yeah, that would be the reasons. Right. So 1 minus, now this is 0.02. So 0.02 means feature Z is basically giving 0.02, whereas feature X is 0.48 something. So we need to pick feature X because it is giving better information gain, entropy. Out of these three, feature X is the best. Internally, algorithm is going to do the same process. So we're trying to understand how that works internally.
Which column it should choose like that?
Right.
Based on
And there is an alternative here, Guinea, but if you look at the template, I've given both Guinea and entropy as part of hyperparameters. Sorry. Somewhere here, given tree, right? Okay, so classification. May not be here, but in classification, they're definitely going to be there. You can see that, right? Relation tree, Guinea, and entropy. So I've given both the options, but mostly we need to rely on the entropy. Okay. I've given it here. Okay, so the next one is Guinea. Guinea is straightforward, very much similar to this one. The only difference, major difference is, it is in entropy we are going to apply log, whereas in Guinea we are not going to apply log. It is straightforward. You can easily guess it like what this value is really mean. For left node entropy, 1 minus 4 by 5, 4 by 5, and 1 by 5 square. That's it. It is 0.31, right? Same way, right node. What will be the value? Like 1 minus. Anyway, we need to calculate. We not to calculate for A because it's 0 by 2
total
square
2 by
minus 2 by 2 square. That is 1. So the overall is going to be 0. The combined Gini index is going to be, that's again the same thing, 5 by 7, 0.32. That's 0.319 being rounded, so 0.32. And 2 by 7, 0. So anyway, this part will become 0 because we need to multiply with 0. So only 0.22. The same way, we need to calculate for feature Z also. So calculate for feature Z and the combined is going to be 0.48. So again, I don't like to rely on Guinea, but even, of course, it's just comparison, right? One Guinea to another Guinea, one feature, one column Guinea to another column Guinea. But we need to rely on information gain. So finally, my conclusion is this is better feature X as per information gain. Even as per Guinea is 0.48, right? For feature Z. When it comes to feature X, it's 0.22. So maybe the reason the Guinea is more lesser it is, more better it could be. I don't know. I need to check the documentation. But anyway, its most reliable one is information gain. Okay. Any questions on decision tree?
Sir, one small question. In the data, they have provided like feature X, feature Y columns, right? So, class A, we have to something like what type, I mean, class we have identified, right? How many in data values are there in feature X? Like here, smart and dump are there. So, class is A and B, like that. Class we have to identify, right? Our
What do you mean
class
by
will be there in the data.
you have completed machine learning algorithm projects, right? So you're asking this question. So class is basically being dictated by the client or whoever provides the requirement. What has to be predicted? What is the requirement? From requirement, they're going to find out what has to be predicted. So based on that, the data will be prepared, right? What
Yeah.
is so difficult about finding out target? This class is basically a target column. In this particular data set, the class is the target column. I've taken a dummy example to explain this concept. If you take a huge data set, it's difficult to sort out like this and explain the concept, right? What is the difficulty in detail in finding out target variable?
Okay, my question was what is class? So it is a target column. Okay, got it.
Class Y? Where is class Y?
No, class. I didn't say
Okay.
class. I
Yeah,
said
class. Okay,
class is a target. Okay,
class
target.
is the target column. Yes.
Okay, and that's what my question.
I think you're totally confused. All right.
No, not totally.
Somewhat.
Somewhat, but yeah, now somewhat clear. Yeah, I will again listen this class, but somewhat clear.
I think you missed the first part. So, okay. The next one is ensemble algorithms. So ensemble algorithms, you might have seen this random forest and gradient boosting algorithms, right? So those are ensemble algorithms. I'll explain what this ensemble algorithms are about. The usual traditional algorithms, after reaching, it try to improve the performance, but after reaching to a certain point, it becomes stagnant. So there won't be any performance improvement, whether the decision tree or loss regression, these sort of algorithms, there won't be any improvement. Whereas random forest gradient boosting algorithms are ensemble algorithms, wherein the performance is going to keep on increasing. Of course, it will have its own limits. When it comes to deep learning, it can be even better. Okay, so these are ensemble algorithms, I can say. These are like traditional algorithms, and this is deep learning. Deep learning is going to be much better. And the whole idea of ensemble algorithm is, instead of choosing one algorithm, instead of choosing like an algorithm, usually the way it's going to work, like we take data and we feed to algorithm, and it's going to generate the model. Of course, we build grid and it's going to generate a lot of models. So the whole live about it. In general, we take data and we feed the algorithm and it's going to generate the models, right? There will be only one model. But as ensemble, interestingly, it is going to generate multiple models. Okay. Let's take that model 1 has weighted 23 as price. Model 2 has weighted 24. Model 3 has weighted 22. Okay. And it is going to consider all the models. Internally, it is going to take all these models. But for us, it's going to give us the average. 22 plus 23 plus 24. Here we have 3, right? 3 models. So it's 3. So what will be the mean? 23, right? So for us, when we feed data to algorithm, ensemble, even if it's ensemble algorithm, it appears as if it is one model. But the fact is, internally, it will have a lot of models working under the hood, like an example here. Okay. And whatever you see is basically like, as if it's one model and giving only one output. That is the idea behind ensemble algorithm. So this is for regression. We're going to average it out. Whereas for classification, let's take that this is A class. This is B class. This is A class again. So binary classification, A class. So it's going to be based on majority vote. Majority, how many, 2 models have got A, isn't it? A is 2. B is being rated by 1 model, right? So it's going to be A. Finally, you're going to see only A, as if it is only one model. It's going to be treated as A. But under the hood, this is how it works. It can be even more complex, but I'm just giving a gist. I hope you got the point, what the ensemble algorithm is all about.
Yeah.
It's a combination of multiple models, multiple algorithms. And average, I already explained this. So it's going to come up with multiple models and it's going to average it out, right? And it's going to give us the final output. And for if it is classification, it's going to be majority vote. Okay. Weighted average, what could be the difference between average and ensemble algorithm and weighted average of ensemble algorithm? But in this case, it is, what is that? What is 22 plus 23 plus 24 by 3 means?
Mean value.
Yeah, mean. But can we write like Yesterday, I think I explained this.
By 3, by 3. Yeah.
By 3, by 3, by 3. So what this by 3, can we write like 1 by 3?
Yeah.
1 by 3, okay. 22 multiplied to 0.33, right? 1 by 3 means
Yes. Yeah.
23 multiplied to 0.33. So plus 24 multiplied to 0.33, which means we are giving 33% weight to everything. So equal weight. That is for normal average. Weighted average means there is a possibility that I may give 30 only for this, and maybe 31 for this. Maybe in this overall it's going to be 1 again. On how much we got from determined?
39.
39. Okay, so 39. So we are giving more weight to bigger values, less weight to less whatever the values that we got here. So this is going to be the weighted average. So basically, what does that mean? We're giving weight to one model more and less weight to other models, isn't it? Let's take in this case, we're giving only 0.3. Again, in this case, we are giving 0.31. In this case, again, we're giving 0.39. Giving more weight to this one. So when this weight being changed and we're trying to find out the average, so that's the whole idea behind weighted average. Any questions on this?
No.
Next one is conditional. What if you have a data set wherein you have both girls and boys data being combined? So in such case, you may prepare one model for girls, another model for boys. Can we write logic like if gender equal to female, use model 1 dot predict data, input data, right? Else, can we write like this? Model 2 dot predict data. This is conditional one, conditional ensemble algorithm. Of course, it's always better to segregate into two different sets of data instead of writing a logic like this. But I hope you got the point. Condition is basically it's based on a certain condition. So if condition satisfies, it's going to pick one model. If condition satisfies another one, you're going to pick the appropriate model or the else condition kind of. Clear? These are more of manual in nature. There is a automatic way. Random forest and gradient boosting internally automatically does this thing. Of course, the logic is going to be much more complex. Any questions on this average, weighted, and conditional?
No, good.
Okay, from here onwards, it's going to be quite interesting. So I request you to focus. Bagging is basically gradient. See, this random forest is based on bagging concept. Okay. So internally, it's going to do the bagging idea. It's going to implement bagging idea. So we not do this manually, but I will explain with an example how it's going to work internally. Boosting, we know that algorithm, right? Gradient boosting. Stacking is more again manual, and these are more automatic. We have algorithms for bagging and boosting. Bagging, we have random forest. In boosting, we have gradient boosting. So stacking, it's going to be used in competitions. It's not difficult much, but we can need even manual, and it's not necessary to. All right, so let's get into bagging first. Let's take that these are all the input columns. Okay, and this is the target variable. Okay. Now, if it is regression problem, it is going to in random forest internet is going to use decision tree as base algorithm. Okay, so it's going to generate. Let's take model 1 on the same decision tree, model 2 on the same decision tree, model 3 on the same decision tree, with maybe variation in hyperparameters or whatever. Okay. So now it's got generated 3 models. If it is regression problem, it is going to average it out. If it is classifier, random forest, we both have regressor, random forest regressor, and classification, we have random forest classifier, right? If it is classification, it's based on majority vote. Random forest does that automatically under the hood. It's the same logic, whatever we have seen, average, same average, right? Average concept in bagging. So there is no difference. But this is more of manual in nature, whereas random forest, which is based on bagging concept, does that automatically under the hood in a more effective way. It is going to use decision tree to generate the models. Random forest, in fact, is a decision tree, but it's not just one decision tree model. It is bunch of models. Got it? You can see that n estimate is 100, 200, right? It means that it is going to check 100 decision tree models. It's going to generate 100 decision tree models. It's going to generate 200 decision tree models. Okay. So internally, it's going to choose 100 and it's going to choose 200. Whichever best is going to pick that one. The reason I have given 100, 200 is there's a possibility that we may get 100 more. No, just with 100 models, we may get best model. If it is limited to 100 itself, the model size is going to be less compared to 200. If we don't get it, so obviously there is a possibility that we may get with 200 trees, but the complexity is going to be more. N estimate is nothing but tree, number of models. Got it? So it's not something new that we already saw that in average. Same
So like
concept in bagging. But decision tree is going to be used as the base model, base algorithm to generate those models. That's the only thing. Yeah, go ahead.
so the two how to know that 100 or 200, like you have written in the bracket, right? Like parameters there.
We don't know whether it's 100 or 200. But okay, you mean to say whether I need to feed 100, 200, or 300, whatever.
Yeah.
You need to keep testing it. So after testing 100, 150, or 200, 250, 300, so again checking the size of the model and the rest and how much time it takes, whether it is improving the accuracy or not. So after several trials, that is what I got, 100 to 100.
Out of 200, we are selecting 100. Is it like that? 100 comma 200 meaning?
And 100 is going to check both 100 and 200. So internally, it's going to use 100 models in one case. Another case is going to check 200 models.
Only two can be given or multiple like that?
We can give
I
more.
mean, in the bracket.
Yeah, we can give
100,
multiple
200,
values.
300 at a time, or like only two parameters can be given?
We can give multiple values.
Okay.
All right. The next one is boosting is a bit complex because bagging is anyway based on average concept. Boosting is a bit complex. Let me explain this. Let's take these are the input columns, right? I'm going to remove this column. All right. So these are all the input columns, and this is the target variable. Let's imagine this is the target variable. And this is what we got from the client. And we applied again decision tree. So even gradient boosting is going to use decision tree algorithm to generate the model. Okay, based on whatever the data that it got. Okay, so data, and it has generated a model, model one. Now the model, again, we're going to feed the same data to the model to predict it. Predict it. Obviously, it's going to come up with Y pred, right? Model pred. It will come with own predictions. Obviously, we can find out the error also. How much it is really is 20, but with the model that we got from this data using decision tree, we got 19. How much error we got? 1, right?
1.
This is again 21, 6 means 5. 5, 5 means 0. 16, 6 means 0. 18, 8 means again 0. Okay? We got errors. Right. Perfect. So these are all the errors. Now we need to copy these errors. This is one loop. We need to copy these errors. Need to paste. Sorry for that. I don't know why it got. We need to copy this error as an input column. Now, how many input columns you have? You already have 3 input columns and 1 target variable. Now you got an additional input column. So 3 plus 1, 4 input columns, right? Here, keep this no target values as it is. Any questions up to here?
So inserting that column, what will it have? What will happen?
No, I will explain it. At least you understand the
Till that
concept.
we got, yeah, got it.
Asking that, okay. The next one is, okay, so any questions up to here? We need to add these errors as a new column to already available input columns. We need to keep this target column as it is. And this error, basically this compared to these values, it has much less value. So this column, there is a possibility that this column is completely ignored. So what do we do is, in order to balance this, we may add 10,000 or 20,000, whatever. So we have something called weight. Let's take 30,000. Each of these values. Okay. So that this column will not be ignored. That is the whole idea behind it. There is no limit to how much value we want to add or multiply, whatever it does. Algorithm will take care of that. So just to make sure that this column will not be ignored compared to this one. If these are already in proportions, this will make sure that this data also going to be in proportions. So that is going to apply scaling. Okay, got it? Any questions? Don't ask me questions at the end. That's the reason I keep on asking like whether you understood or not. Of course, I'm not going to get a proper response. That's a different thing. So at least someone should respond. Any questions on this part?
No, sir.
All right. The next one is, it is going to, it's going to be fed to, this data is going to be fed to algorithm tree. This data, when I say this data, this data along with the new column. And it's going to generate a new model. Okay. Once we got the new model, we need to predict it. Right, based on what? Right, based on this data. So it's going to come up with its own predictions, isn't it? Now it is Vibrate 1. We already have Vibrate. Let me Vibrate 1. Okay. Model. So model bits. So I'm going to replace this. No, this one as model Vibrate 1. Now this may be something like 19. Okay. And this can be 18. This can be as it is. Okay. Now what is the error? 20 minus 19, 1. 21 minus 18, 3.
2. Sorry, 3.
3.
21,
Remaining are zeros. Okay. Now again, another loop. This is going to be copied and pasted here. Again, it's going to add some weight. So make sure that this column will not be ignored. Again, once we add it, this data we're going to feed to relation tree algorithm. And it's going to generate another model. I need to predict it. We need to feed back the data. And it's going to come out with rate 2. Okay. And we need to calculate the error again. So so it's going to do in multiple loops. The point is, what it's going to do is, when we get error, okay, so obviously wherever we have the bigger errors, it is going to focus on those rows. Suppose in this case, it's going to focus on this row, ignoring the other rows. It's not going to focus much on that. It is trying to reduce this error. When it keeps on trying to reduce in every loop, when it tries to keep on reducing the higher errors in every loop, what happens? It is going to keep on improving
models, yeah.
performance, right? In bigger errors. The reason why we add this error as a column and add weight, of course, we add weight because to make sure that this column will not be ignored. But why we even need to add this error as a column? To make sure that wherever we got bigger errors, those rows will be focused more. So that we can, and the algorithm will going to focus on those rows to keep on reducing the error. So when we keep on reduce the error, obviously performance will keep on increasing, right? Improve. That is the idea behind boosting. So that is how gradient boosting algorithm will work internally. Any questions?
No, sir.
No, sir.
Next one is stacking. So stacking is more going to be used in competitions. It's not really complex, but again the same concept. Let's take the ration tree. It can be here we can internally gradient boosting or random forest going to use ration trees. But stacking is more manual, right? We can choose any algorithm. Let's take in this first case we have chosen ration tree, another the same data set. Another case I have chosen logistic regression, another one gradient boosting. I've taken 3 different algorithms. Each algorithm will generate each model, right? No issues. And again, when we feed the same data we put to these models, right? We're going to get some predictions. Model 1 prediction, model 2 predictions, model 3 predictions. Any questions up to here? The same concept, just the algorithms are different. You can even use the same algorithm with variation parameters. That's all. This part clear?
Yes.
Okay, so now we got model 1 prediction, model 2 prediction, model 3 predictions, right? Of course, we have target. Now, what we do is, if here in this case, I have taken only 3, but there's a possibility that we can even have more models. All right, so this model 1 predictions, let's take that we're going to choose 3 and 3 different algorithms. It's not the same. It can be even the same algorithm. Model 2 predictions and model 3 predictions need to add as an input. So we need to pile up, like as if it is set of input columns. This is model 1 prediction. Okay. This is model 2 prediction and this is model 3 prediction. Now this became, we need to consider it as an input. And target column, we have that. And make it as a target column itself. Of course, here it is, I have given 1 0 zeros, but it can be regression, you know it, right? 1 6 5 0 something, so whatever it is. I given, it's not just 1 0 zeros. That is what I mean to say, right? It can be any value.
Continuously that anything. Yeah.
Whatever the model has created, we need to add it up here. So here I have taken 3 models, so 3 inputs we got, 3 input columns. And target is as usual, there won't be any change. Now, we need to take any algorithm. Basically, we are going to take the best model, best algorithm. Mostly Bayesian tree is more reliable. Or you can even use gradient boosting or random forest or whatever. We're going to take that algorithm. We're going to train this. We're going to feed this as an input, this as a target variable. And this is going to generate the model, isn't it? This part.
Using all the predicted models, it's going to generate another one single model.
Again, you are messing up things. The reason why I ask you this question is whether you understand or not. So I told you that this is not we got predictions based on the model. We are taking these model predictions as an input. The actual data we are taking it. We are not taking the models. We are taking the model predictions, predicted values. These are not models. These are predicted values by those models with respect to models. And this target column as it is. In this case, there's nothing called models in this particular level, at this particular level. It's all data. And we can take any algorithm and we can feed this data and we're going to generate a model. That model is going to be the final model. We are feeding the model predictions as input. Okay. Model is at this level, it is model. But after feeding this data to this model, obviously it's going to come with its own predictions. The same way for model 2 and model 3, the same data.
Yeah.
This is the data that we got. Target as usual, the previous one, the original one. And final model is going to be whatever the algorithm that we apply, we're going to have its own model. That will be the final model. That is stacking. So basically, we instead of relying on one algorithm, we are taking multiple algorithms. Again, we are training it on the output data or predicted output data. and then that is going to be the final one. So instead of averaging it out or majority vote, what we are trying to do is we are applying another algorithm in stacking. We basically in average, what do we do? Once we get it, we are going to average it out. Or in the case of classification, we are going to pick the majority vote. That is what bagging does, right? But we are applying another algorithm on this output data, predicted output data, keeping the target column as it is. That final model, whatever that is going to create at the end, that is going to be the final one. Clear?
Yeah.
Next one. Hyperparameters will take time, so we'll discuss it on Monday. We'll conclude it on Monday. Hyperparameter, what else we remind? I think all the concepts got completed. Of course, I will explain this principal component analysis later. It's not really difficult, but soon that later. So remaining cons been completed. So most of the machine learning intervals got completed, right? Any questions in today's session?
No, sir.
Sir,
So, yeah,
Go ahead.
go on, go on.
yeah, I mean, it's not related to exactly this one, but somewhat like I know this concept is completed, but I'm sorry to ask now, but my question is, so we suppose once we receive the data, we have to write all this code, right? For whatever now we are using your code, that we have to write it, right? In the real life when we are.
Which code you are referring to? Which concept you are referring to? What do you
I
mean
mean,
by writing?
no, not only the single concept. Suppose you client has provided the data, then we
Okay.
have to like use the algorithm and feed the data to algorithm to generate a model, right? There won't be
Okay.
any like if it is from scratch, we have to write it on our own, or how it will be in the real work life.
Oh, why do you think that I given template? Why did I give template to you? ML internals is basically once we have the template, we're trying to understand things that are under the hood. Here we have used gradient boosting random forest. We don't know how this works. We don't know how lasso ridge elastic net works. That's the reason I explained L1, L2, L1, L2, right? Combination of L1 and L2. Decision tree. So do you think that anything we missed? I'm trying to explain things that are under the hood after I have provided you the template.
Yes,
So we just
I
have to
understand.
mug it up that's it, this templates and all.
Sorry?
Do we have to mug it up this template? How to write? If we are given, as it told, we are given a data, right? So we have to learn this template so that we can insert that same thing in the
Right,
real time.
that is my way of explaining it. So it's whether you're going to mug it up or you're going to
Understand?
keep
Okay.
it's your wish. But no, I was quite surprised with your questions. After providing template, after completing
No,
several
I'm see, you
assessments,
have
I asked,
provided for our
no, no,
understanding.
no,
I'm not denying it, right?
no,
My
no, no, no,
maybe
no, let me complete. Let me complete. You
sure,
asked me a
please.
question whether you need to write from scratch or not. That is your question.
I mean, that is not exactly my question. Sorry to maybe if I miscommunicated. I'm not asking with respect to like now practicing or anything. Suppose after 6 months or 1 year, if I joined as a AI engineer, I mean, maybe it is a simple question for you, but I'm a learner. So I'm asking in real life, in the project or somewhere in the company, will there be any standard templates like that? Of course, again, that is dependent, but will there be any templates like this, or we have to prepare at that time on our own? I'm not asking for the practicing now. I understood he gave us for practicing, but how it will be in the office like that, I'm asking.
Okay. No, see, the management will take you as an AI engineer. And do you think they will prepare template and give it to you? Or
Yeah,
if
there
it is a
won't be
technical,
any but yeah.
yeah, if it is a technical team, even if it is a technical team, and if they already have templates and they don't require any AI knowledge and just blindly executing it, then do you think that you may be required? So it's not just templates, you require things, you need to understand concepts under the hood. That matters a lot. Template is something that I have given to you, whatever the process that I follow in real time. I'm giving as it is so that it is going to be helpful to you. And in fact, I have modified it heavily to make sure that it is going to be as simple as possible to beginners. You can take this and deploy, use it in production. There's nothing wrong in it. But if you want to write from scratch, it's your wish again. They are not going to provide any templates to you unless someone is experienced, and if you ask scripts, they may share some scripts to you.
Okay, yeah, got it.
So if you want to learn it, I mean, write it on our own from the scratch. So how do we so completely understand it? Then we should start writing like that, right? Yeah, that's what
Yeah.
you are telling.
Yeah. It's up to you how you write it.
Okay. Sir, I have another doubt regarding this algorithm. So the classification and the regression both having the same algorithm or like different? I mean, we have come up with this one, right? Lasso, ridge, and all. Uh,
Okay, so do you think
they
that
both
we
have.
have the same set of algorithms?
Mhm.
Do we have same set of algorithms? Loss regression, and where do we have lasso? Where do you have lasso, region, elastic gradient classification? We don't have, right? Loss regression. Random forest gradient boosting, decision tree, multinomial, NB, Gaussian, NB, and do we have it here? So it's
No, no.
not all the algorithms being fitted for all the cases. Regression is set of algorithms are different, classification
Hmm.
algorithms are different, but in some cases like random forest and gradient boosting, they provide even decision tree, they provide both versions, regression and classification. But not algorithms going to work for both. Of course, again, it is totally different. This algorithm, even though the name is same, is totally different under the hood. The logic is same. I told you, right? The average and majority vote. In the case of classifier, it's going to use majority vote. Whereas in this case, it's going to average it out. Those sort of things going to change.
So decision tree is separate, and the gradient boosting also internally uses the decision tree, right? Hello.
Uh, Gradient boosting is basically a mechanism going to be implemented by algorithms to find out the optimal parameters.
Yeah.
Gradient boosting is not an algorithm. I mean, basically, if you gradient boosting is an optimization method that is going to be used in all the algorithms. Even in the while I was explaining stochastic gradient descent, I have taken linear regression and told you that linear regression under the hood it's going to use this gradient descent. Gradient descent is a mechanism to optimize the parameters. And you are asking me where gradient descent uses decision tree under the hood. Gradient descent is an optimization technique that is going to be used in all the algorithms to get the optimal parameters.
So the ML internals it will be concluded by Monday, right?
What was your question? What are you
I mean,
asking?
I got this point, so I'm just
Ah,
asking that question.
yes, yes.
So after my conclusion, right? So can you just tell the steps after, like in the machine in learning internals? What are the steps? Just like, I mean, 2 minutes. So these are the steps that will going on. That like.
What do you
Yeah,
mean by
yeah,
step?
sir. Yeah,
What do you
that
mean by
is
step?
also, I mean, yeah, we know that you explained us everything, but in short, to be very clear in our minds, once
No,
we
no,
get
I'm not
the,
going to explain that. Yeah, I got your point. I'm not going to explain. I'm not going to give it just because it is very, it does, it's not possible to explain it in 5 minutes. You have to practice it. What do
no,
you
sir,
mean by giving
please
a
try.
gist?
Yeah, yeah, try to understand. Take 10 minutes. See, see, maybe, sorry to ask like this. Maybe for you, these are all not new things.
No, 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 don't worry about me. No, no, don't worry about me. Thing is, when I take almost weeks time, do you think that I'm mad? Obviously, this will take time to practice. Even when you see explanation, try to explain as slow as possible. The point is, if you don't practice on everyday basis, if you don't repeat on everyday basis, obviously this sort of questions will come. So
it
you're
doesn't
asking
mean
me
that we are
to
not, see, sir, please,
okay. Can I ask you a question on ML internals, whatever I have
no,
explained?
if you ask, I cannot answer. I know that one.
Then how
See,
come? Then
we
obviously it tells that you lack practice, right? No, don't ask me just because it is not possible to explain in 10 minutes. That's the reason I have taken weeks' time. Why do you think that I have taken so much time? Show me one course that they take 1 week time for ML internals. No one will take it. In fact, they don't even explain ML internals.
Sir,
Even
you are
after
explaining
doing that,
internal every algorithm very clearly. Really, we are very thankful and we are appreciate that one. See, but sir, if you are not okay, then we are asking 15 overall, like there are stepwise like that. If that is not the
okay. So you mean stepwise. Why do you think that I ask you to execute project step by step? Try to understand the purpose of each block. When I explain ML internals, you'll try to map it, right? That's the reason I came up with this template and ask you to try to understand the purpose of each block. Execute one by one. Why do you think that I explain it like that? So do you think that it is possible to explain in 10 minutes? I have taken almost 3 weeks to explain this. So right from mathematics and statistics, this outlier proportion, when do you think that I have explained it? This whole logic, you can go through the outlier concept. You are trying to explain me in 10 minutes or giving a gist of whatever been explained. But that is not possible. That's the reason I have taken a lot of time on this. And still you have a lot of complaints on that. And when I complained about practice, and you are saying that no, we are practicing it. When I ask you, when I ask you whether I can ask you any questions related to that, no.
I didn't say no. I said if you ask also, maybe I am not in a position to answer.
Why? Motion means why? Why not?
Yeah, it's a new concept to me. I am learning and I'm still
So it's a
I am
new
in the
concept. It's a new concept. That's the reason and
yeah,
explanation.
I am not good at understanding. I am not a quick learner. So I need, 6 days is
Obviously,
not sufficient and I need more than 6 days. It can be 1 month like that. See,
then
I just,
no, then it's not my concern, right? You have to take time
yeah,
and
it's not your concern, sir. I mean,
no,
I said,
my point is simple. It is not possible to explain and to
okay,
give a
then
gist
fine.
or
Yeah, yeah,
no
you
in
said
10
it's
minutes.
okay, then.
I have taken a lot of it definitely takes a lot of time. I have taken a lot of time to explain the concepts.
Okay, yeah, agree.
I've
Yeah,
done my job, and it's your job now to how much effort that you put on, like how much effort that you put into that, and how much practice you do. It's your choice. I've given all the scripts, all the explanation, and it's in your hands now. So it's not possible to explain in 10 minutes. Yeah, that's all.
yeah, then fine. Yeah.
When it comes to sequence, how it has to be followed, again, I have given it in template. All right, that's it. I'm seriously no concerned about the way you're asking questions. And very disappointed, I can say. It's not even concerned. And not just this batch, even the previous batch, that batch. All right, thanks.
Yeah, thank you for the class.
Thank you, sir. We are not pointing out anything. Just I have.
No, leave it.
Okay, then. Yeah.
I
Thank you.
had
Yeah. Thank you.
enough of this nonsense. Thanks.